Hi class. Today we will be starting with Unit 1. It's just a plastic bottle of water from your Y Environmental Science textbook. So the point of this unit is to basically help you all understand the giant importance of water, whether it is the water that we drink, which of course is fresh water, water in the environment, how water moves through the environment and through earth, energy that moves water. So yeah, you guys will be getting an in-depth lesson on water. And water really is the most important, not element because it's made up of different elements, but it's the most important resource that we have on Earth. And as you can see here, while it may seem like it's, an endless supply, there is only a small fraction of water that is accessible to living beings because every living being needs fresh water, right? And this picture that your book uses is an extremely important representation of all the fresh water, accessible fresh water on Earth compared to the amount of surface area of Earth, right? So it's pretty crazy how much water we actually have on Earth that is available for drinking. As I explained to you, we will see how water cycles through the environment, the reason why fresh water is becoming scarce, review the process of science in terms of water, how data is analyzed, and fact checking and how we come across new scientific information. And then finally, what are the roles of sciences such as chemistry and toxicology in environmental science, which process wastewater and move different elements, minerals, toxins through environments through water. So that will also be covered. I want everyone to keep in mind that environmental science is a multidisciplinary science that encompasses a lot of different other sciences. That's why you will see me talk about hydrology, toxicology, chemistry, ecology, etc. So, Module 1, Lesson 1, what is the water cycle? You probably have heard already of the water cycle. This is something that has been drilled into the brain of everyone since we were kids. We are going to briefly revisit it, and we will discuss how water is utilized and how it cycles through natural systems, different sources of fresh water, and what are the main uses of water, both agriculturally, industrially, and in the home. Here, I like to put a little picture. This is a personal picture of a wetland. So wetlands are ecosystems that stay flooded throughout the year, and we will be going in depth about different ecosystems that have water and how it behaves. So how much of the Earth's water is drinkable? Well, as I explained to you, there is a limited amount, a very small limited amount of fresh water available. This picture depicts how it is split up into how water is split up in the entire world. So as you can see, most of the water on Earth is saline salt water, right? So 96.5 in salt water, and then there's 0.9% of other saline water, meaning that the only 2.5% of water on Earth is fresh water. And then we further split that into groundwater, glaciers, and ice caps, and then surface and other fresh water. Now, that 1.2% of surface and other freshwater is what we can mostly see available to us. That is lakes, the atmosphere, ground ice, and permafrost, rivers, swamps, etc. So it is a very small amount that is readily available. Glaciers and ice caps are not readily available, and that's why we don't really consider them such a great source of fresh water. We do use groundwater, especially here in South Florida. We draw most of our water from the Biscayne aquifer, and I'll talk about that a little more. So where can we find water? Where, as we know from the water cycle, it exists as water vapor moving within the air and atmosphere above Earth's surface, as a liquid flowing in a river, or in standing water as lakes, and solid ice as in glaciers or snow. So the water moves in a cycle, and there are various phases that are distributed all around Earth. It is estimated that at any given time, there's about 3,100 cubic miles of water as vapor in the atmosphere, right? And each cubic mile is 1.1 trillion gallons, not billions, not millions, trillions. So that's a lot of water in our atmosphere, and yet it is a small percentage based on that diagram that we just saw, figure 1.1. And if all of this water fell to Earth, it would only cover to a depth of around 1 inch. That's why it's crazy to think that 1.1 trillion gallons is not even that much. So you guys can really see how much water is needed to sustain life on the planet, and it's quite a bit. So here is the basic water cycle. You might have seen it as a child and in elementary school, and then further elaborated upon in middle and high school science courses. It's very simple to comprehend, right? So plants uptake water through groundwater, through the soil. They do photosynthesis, and one of the byproducts of photosynthesis is transpiration, which then it evaporates water into the atmosphere, becomes condensation, gets transported by winds across different lands, falls as precipitation, or even in mountains as snow. It gets ice packed, and then when it gets heated, it can become snowmelt runoff, and then eventually surface runoff, creating rivers such as the Amazon River, and then eventually infiltrates back into the groundwater. So these are things that you guys already know and can easily Google. So I don't think anybody will have any problems understanding this. But if you want a better definition for the names of those processes, well, here you have evaporation and transpiration. If you guys want to pause the video and copy down those definitions, definitely do that. Next, condensation, precipitation, and something cool to know is that in the lower 48 states of the US, we receive about 4 cubic miles of precipitation each day. And there are different forms of precipitation. I put just 4 of them here, but NOAA, which is the National Oceanic and Atmospheric Administration of the United States, has even more categories of precipitation. These are just the major 4 that everybody uses. So as I mentioned, only 3% of the water on Earth is fresh water, and only of that 3%, only 1% is accessible surface fresh water. So what are those sources of rare surface fresh water? Well, that would be your rivers and lakes, right? Which get refilled from precipitation, and then mostly top layers become lost due to evaporation. And then solid precipitation like snow and ice can accumulate over the cold winter months, storing the water until temperatures warm in the form of glaciers, or even there is permafrost on the ground that collects. So you may have seen glaciers when you've traveled up north, and that is snow and ice that has been compacted over a lot of years, growing into large masses of ice and snow. They also move very slowly due to the pull of gravity, and even glaciers have been recorded to travel several inches a day. There are a few places on Earth that meet conditions for glacier formation, so they are very rare, with only 200,000 on Earth today. And what we have seen with climate change and, the planet becoming warmer, they are much smaller than what they used to be 50 to 100 years ago. Here is a beautiful picture of the Perito Moreno Glacier found in Patagonia, Argentina, and it is one of the largest in the world. The Patagonia region of Argentina is known for these massive, beautiful glaciers, and it is because it is at a lower latitude on our planet, which allows for the conditions of glacier formation to happen. The rest of fresh water, around 30%, is found underground in aquifers. And this is important because an aquifer is defined as rock or sediment that contains water. Now, you can have aquifers that are confined and unconfined, right? So what that means is that it's easier for the water to percolate and kind of seep into the spaces underground if it's unconfined. When it's confined, it's very difficult because it has like a very solid, compacted layer of rock on top of it, which does not allow for precipitation to flow as quickly in. Water can move underground, right? So we saw in the water cycle the groundwater flow between places. And so here in Florida, we do get our water from the Biscayne Aquifer, but there is also the Florida Aquifer, which is a little bit higher and more to the west of us, that is used by other portions of Florida. The Biscayne Aquifer is recharged by water that comes from the Everglades. So the Everglades actually begin in the Kissimmee Lakes a little bit above Orlando, and then they run down in a slow-moving river fashion into the Lake Okeechobee, and then from there another sheet flow begins down into the Everglades. While this is all happening above the surface, water is slowly seeping into the limestone bedrock underneath and being basically purified until it goes into the aquifer, which then we pump here in South Florida to get our water. Okay, now the rate at which an aquifer recharges is dependent on how close it is to the surface and then what types of rock or sediment are found between the surface and the aquifer, right? So here in Florida, we have a limestone bedrock that is very porous, and so the recharge rate is a little bit faster than what you would find in other places with a denser type of rock. And changes in land usage can impact the recharge rate. So what we have seen is that high levels of development here in South Florida have basically decreased the amount of recharge or have contaminated recharge, and that's a big, big problem. Here you guys can see more information about confined or unconfined aquifers, right? So a confined, as I explained, has a layer of impenetrable rock or clay above and below the water, meaning that the water is often under pressure in that aquifer. They are slower to recharge, and they are dependent on the slow filtration of water through many layers of rock and clay. An unconfined aquifer has permeable soil above it, and it is usually found closer to the surface than a confined aquifer. And they are more subject to variation in the amount of water that they contain, and they're more influenced by changes in precipitation. So here in Florida, we definitely have an unconfined aquifer. Aquifers and wells. So, because of how difficult it is to get water from a confined aquifer, people have created what is known as artesian wells. So they go deep into the bedrock, and because of the pressure, that water is able to fully pop out and kind of spill over. So that's really important for those. There's also wells for unconfined aquifers, and we do have them. They're a little bit higher, closer to the surface, as you guys can see in figure 1.4 on the left. Water in aquifers can also be accessed through natural springs. So in Florida, you may have heard we have a lot of natural springs. They're amazing and beautiful, very pretty colors. And there used to be even more than what there is today, but due to development and as they mentioned earlier, the changes in land use changes how much water would come up. So some of the natural springs do not come up in the way that they used to, like this, in which it's basically a cascading fountain. That doesn't often happen anymore because of land use changes. Anyway, so as I explained, you can drill these wells deep into unconfined and or confined aquifers depending on the location. And the artesian wells, they don't really need to be, as I explained, don't need to be mechanically pumped because there's just high water pressure in the aquifer. This is a beautiful picture of a natural spring. We don't see this as much in Florida anymore, but if you go to other places that are volcanic, because of the pressure and the plates moving in the surface, and there's just volcanic activity, it creates more pressure, and thus they can shoot out like this and look quite pretty. However, they are known to be extremely hot, and that's also a huge problem. Well water is often preferred to surface water sources for drinking because the movement of water through layers of sediment and rock provides filtration, removing chemicals and pesticides that are found at the surface. So, as I explained, when the water is traveling down the Everglades, it is cleansed by plants, and just in general the minerals and elements in the soil, it cleans that water before it goes into the aquifer. So here in South Florida, we have some of the best drinking water anywhere else, right? um and you might have been able to taste that because if you go to other parts of Florida, it might have more of one element that isn't as, tasty or wanted. So it is really great that our fresh water here is cleaned through the aquifer and through the percolation of plants in the Everglades. In the Midwest, a lot of areas do not receive enough rainfall each year to productively grow crops. So there is high levels of competition for water resources, and there are limits on the number of wells that can be established in the same aquifer. So it can draw a lot of conflict between people. I saw this myself in Colorado, in which land rights also give you water rights, and the way that each piece of land could draw from an aquifer was based on historical documents that gave basically a numbering system of like 1 through 10 to each land plot. And so the number 1 would get the most water, and then it would go down the line, right? And then when it would get to 10, they were not able to draw as much water because the other ones had obviously taken more water. This has created a lot of conflict between people, particularly over there where they use that land for farming. So it's kind of impressive. Another thing I want to know is that the lack of precipitation was one of the main causes of the Dust Bowl, which lasted from 1931 to 1941, right before the US entered World War II. And what basically occurred is that there were strings of droughts that dried the soil throughout the Great Plains. And because of that, a lot of millions of acres of crops and grasses basically died, leaving no plant cover to hold the soil, which then, when the wind blew, it began these giant dust storms, right? The loss of agricultural production in this region was a contributing factor to the Great Depression. So, as you can see, water is an extremely important resource because it can affect anything down the line in terms of the national economy. We are a major agricultural country, so that's a pretty big deal. One of the most massive aquifers in the US is found beneath many of the plain states that you see on figure 1.6 to the left. It is called the Ogallala Aquifer, okay? And it has allowed agriculture to flourish in places that do not receive large amounts of precipitation. And then as more irrigations are drilled into the aquifer, water is removed much faster than it can be recharged. Increased rates of withdrawal have reduced the overall size of the Ogallala aquifer by as much as 150 feet in some places. So water levels have decreased by that much. Once the water of this aquifer is completely gone, it is estimated to take around 6,000 years for it to be recharged. So that's a big, big problem. Now, think about yourself. How much water do you think you use each day? And you may think, well, I just take a shower and I drink 1 gallon and I go to the bathroom 3 or 4 times a day. So I don't think I use that much water. But we use water indirectly and directly every day. It's used to support the livestock and crops that, are used to make the food we eat. And that's why it's really important to think about how much meat consumption we have, because we've seen that to produce the beef in one hamburger, it takes like 660 gallons of water because, it's used to irrigate the crops. It's used to feed the cattle. It's used to irrigate the crops that feed the cattle, and then just providing drinking water for the cattle and cleaning cattle and making sure, it's transported properly, and then to process that meat. So we cannot just think about water in what we see, but think about it in the production of what we eat or in what we use. Industry uses large amounts of water because of the fact that its unique properties allow it to cool heavy machinery. So just to make one car, it's about 39,000 gallons of water because you're using heavy machinery that needs to be cooled down. If not, it overheats and could potentially cause damage. So you need large amounts of water to cool these huge engines that produce metal sheets that are running all the time. Even the clothes that you're wearing need water to be produced. So 1,800 gallons of water are used to grow the cotton to produce fabric. The latte that you drink, you think it's just 8 ounces of water. It's been estimated to be actually around 53 gallons if you calculate the amount of water needed to irrigate the coffee crop, or the vanilla that, will then be put in the latte. So it all depends on how many ingredients you use. It all adds up. And then finally, for the plastic bottle used for bottled water needs, there's almost 2 gallons of water, not just 16 ounces, it's 2 gallons of water. And then in other parts of the world, water is used to generate electricity. So, that's even a greater amount. Now we're going to move on to talking about energy. The movement of water is commonly used for energy production. So hydroelectric power plants use the flow of water either from a river or from the storage of water behind a dam to spin a turbine, which can be used to generate electricity. About 7% of all electricity generated in the US comes from hydroelectric power plants. Now, you might be thinking, oh, but this is a renewable energy source, so it should be good. Well, I have my problems with dams. Dams have been found to be very damaging to local ecosystems and even to the livelihoods of people. Because when dams are built, there needs to be a reservoir to withhold all that water that is collected or being withheld, right? Sometimes those reservoirs are massive. Think about huge dams like the Hoover Dam or the Three Gorges Dam in China. These reservoirs basically need to hold back trillions of gallons of water into a location that previously did not have that much water. So what happens is that these companies will begin to start flooding nearby communities, and basically buying out small towns, small rural towns along the the lakes and rivers in which that they will create the reservoir. So that's a big problem. As for ecosystems, we have seen that dams change how rivers flow naturally, and rivers and water carry sediment downstream, which can provide critical habitat for different species. When that water is withheld, it doesn't make those habitats, those microhabitats anymore, and they have seen huge changes of fish and insect communities because of that. Well, besides that, there are other forms of energy produced by water movement, the movement of water in the oceans, either from the changing tides or waves, can be used for electricity generation. So in areas that there are high differences in low and high tides, 40 to 50 feet, that change can be harnessed and converted to electricity. And so what happens is as a wave passes a location, there can be a turbine or some sort of device that takes the wave energy, converts it into mechanical energy, and thus generates electricity. One of the more common places where we see this is in bays. Tampa Bay has a crazy change in tides. This example here is in New Zealand, where you can really see an inlet that has a high tide and a low tide that is drastic. And so they would set up across from that western point that you see in the first picture all the way to the other side of that inlet, kind of like a rope with a device or several small devices the along the rope, which would capture that energy and then connect it to a generator. I couldn't find a picture of one, but this is a pretty good example of where they would set up one of those devices to capture electricity. Now we're moving on to agriculture. So as I mentioned before, water is used in large volumes for agriculture. Precipitation alone has been shown to not support enough water has been shown to not provide enough water to support crop growth and therefore irrigation. Nebraska and California have the largest shares of irrigated land, accounting for nearly 30% of all irrigated land in the US. And that's because these two are massive agricultural states. We are one as well, but we just don't need irrigated land due to the fact that we get high levels of precipitation. The amount of land that is irrigated has continued to rise over time. At this point, around 60 million acres of land in the US are irrigated, and that's because we have a lot of people to feed. Modern medicine has improved and lengthened life expectancies for a lot of people in Western societies, and thus we have a large population that needs to be fed a lot of food. and thus we need large volumes of water. Other ways that water can be used in agriculture is that it is essential for sustaining livestock. Think back to that hamburger example. Milking a dairy cow can require up to 50 gallons a day. Water is used to apply fertilizers and pesticides to fields because usually you get a concentrated solution that you will need to dilute in water to spread over your fields. Water can help preserve and cool crops by decreasing the temperature of a field in very hot weather. And it can also be used during a cold snap to prevent the freezing of some crops. Like in strawberry fields, they can irrigate plants to prevent the freezing of the fragile berries in unexpected cold snaps, right? We do that here in South Florida. We get those random December, February, January days that could go into the 40s. And so farmers need to be prepared by basically just like spreading water quickly throughout the fields, and that allows them to not get as frozen as fast. Even though you might think that's counterintuitive, but the unique properties of water allow it to not freeze as fast. Okay, so about 40% of all fruits, nuts, and vegetables are grown in the US, come from California. It is the farming and production of water-intensive crop relies on irrigation, with many parts of the state in exceptional drought conditions. So California is constantly going through droughts, and that is because of, well, high population demands in their large cities such as LA and San Francisco, but also just in general, the massive amounts of agriculture really take all that water. Supplies of groundwater continue to fall because recharge rates are just not high enough, and thus restrictions are being put into place so that some regions can't freely use irrigation as they used to. In 2021, the state of California implemented the Sustainable Groundwater Management Act, which limits the amount of groundwater that can be taken out each year to the amount that can be recharged into an aquifer. And in some regions of California, nut trees are being taken out due to their high water demands. Crops that can be grown in other parts of the country, like corn, are being avoided to allow more specialized crops to grow, including fruit and avocado trees. The lack of water is a huge concern that in the future, some farmers may not be able to grow crops and may need to turn their land to other uses, such as solar farms or wildlife habitat. Here you can see a beautiful row of almond trees in bloom in California. Now, if you look closely, you can notice the presence of irrigation lines, which are the black tubes, and beehives, which are the white boxes. And so with this big restriction on water management, some of these trees are not doing as well, and California has had to cut back on its amount of almond production. Now, how does this relate to you? Well, let's say you love almond milk. It's really important for all of us to acknowledge the impact that we have on the environment and on our society. So as more and more people turn to plant-based milk, such as almond milk, they don't really realize the amount of water it takes to produce just one carton of them. Now, in the industrial aspect of water usage, yet again, a lot of water is used. Here are some of the examples, and I've already talked about them: textile and garment, the production of food and beverages into packaging, steel production for cars, for buildings is very water intensive. As you can see, 62,000 gallons to create 1 ton of steel. Even electronics requires water for production, and mining operations is really, really water intensive because you use pressurized water to separate the contents out of rock mixtures, right? So you get an ore. An ore is a valuable rock piece. I'm gonna simplify. A valuable rock piece. And when you shoot high amounts of water, it splits up. And so you can draw out the specific minerals that you need from that ore. And that's why water is used in mining. Household water usage. This pie chart shows the various uses of water usage in the home and how much of the total water usage it each accounts for. Each day, a person in the US uses around 80 to 100 gallons of water. So remember how I mentioned you first thought it was just like, oh, my gallon that I drink for the day, and then I go pee and, do number two or three times a day, or 4 or 5 times a day, and then I take a shower, but it's only a 30-minute shower, so it can't be that many gallons. It is a lot. And this is what I want everybody to keep in mind. For a day, really look how many times you open your faucet, right? To wash your hands, to wash your dishes, to do this, to do that. It adds up. And the problem is that I've noticed more and more people don't take into account how much water they use, and that they just leave taps running. I'm very strict with that. Taps need to be closed in my house, no leaking, nothing. The minute you're done, taking a shower, you shut it off. Shower should not take more than 15 minutes, and even then, that is a lot. You just need to go in there, do your business, and walk out. It's not a place of meditation, of relaxation. I understand that some people like that, but we are facing a worldwide water crisis if we don't start really being more regimented with that. So here is one of the more explanations about how you can reduce your household water usage. There are innovative technological machines like low flow shower heads or water efficient washing machines. Leaks can also add up to a large water bill, so it's really important to fix dripping faucets and hoses that can save water and money. There are several programs that have been implemented to reduce water usage. Here you can see some of them. The Energy Star program in 92, which you may have noticed the Energy Star sticker on one of your appliances. And these agencies set water use and energy criteria on appliances. So that's it for this section. Thank you all for joining, and I'll see you next time.